Hello everyone, how's it going? I hope everything is good. And hopefully we won't have any issues this time. So yeah, once again. Hi, we are going to do Snark News Winter Series round 4 today. We have already done 3 rounds on stream and you can find all of them on my YouTube channel, all the previous ones. And yeah, the round is 80 minutes long as usual and it will have 6 problems. They will be in Russian, but I will translate them into English. Just using an automatic translator so that you can read them too. Yeah. And yeah, once again, I will do the problems competitively, and then after some time, I will be up to discuss them. But before, like during the contest, I will not be reading the chat, so feel free to discuss whatever you want, and you can even discuss the problems. And then I will be probably mumbling some words so that maybe you can understand something as I'm solving the problems. Yeah, thanks for the wishes. Tomorrow I will most probably be participating in Code Forces. Not 100%, but most likely. And yeah, we'll try to boldly go, you know. Try a contest in Rust. Not today, but I'm down to try it at some point, but I have to learn it a little bit. Like I don't really know it well. Anyway, today we are using C++. This is Farm Manager, not Turbo C++ as some people assume. Yeah, when I'm using my laptop, I'm mostly using light theme, not dark theme. So I guess gotta bear with it. Not cold, thank you. Do I love? Well, not really. Like, I understand it's mostly because of maybe the highlight in scheme and like even more just about the background, like the blue background is just associated. I am from Belarus, but I'm mostly live in Russia. Sometimes I am in Belarus. How I added algo debug H? Just in my, somewhere in the G++ library folder. I'm not streaming Division 1 tomorrow because you cannot stream live Code Forces contests. But you can stream Snark News Series for various reasons. And that's what we'll be doing today. Yeah, I will start in several minutes. Yeah, maybe in in 1 minute. Let's start in 1 minute. Can I record and upload on YouTube tomorrow's Division 1? I'm not really doing screencasts. I don't know. I think it will be a bit distracting for me. So yeah, I probably won't. I don't know. I think that streaming should be like when I at least like can mumble something, or maybe even when I do Code Forces Division 2, you can see what, like, I can also explain the problems. That should be more watchable than just screencast. I think that screencasts are not really a great format, right? Would I stream at Coder sometimes? Yeah, I was considering that. Maybe I will. Like, at Coder only has contests on weekends. But yeah, I might stream at Coder as well. Yeah, I guess in 45 seconds. Okay. So, once again, see you on all in 80 minutes. Or maybe sooner if I finish sooner. And yeah, feel free to discuss the problems, and good luck me. Okay, I look like some data structure problem. Mm. Yeah. Okay, this example is really sad. But yeah, I have a tree and I have some queries. How many paths starting from SI? Yeah, I don't know. Okay. Probabilities, probably not the easiest problem. Geometry, I mean, okay. close. Okay, F must be the easiest, right? Yeah, this is pretty hard to read. What? Okay, so T out of this number reached the finish line. Triangle, okay. Okay. And the trucks are neighbors behind the truck. Okay. Yeah, okay. How to solve this? Some dp, but which one? I have some. Yeah, like I go to top to bottom maybe, and I have some number of tracks. Yeah, all segments become one longer. And what next? Yeah, I don't see it. Okay, D. Okay, I didn't really understand this problem. Okay, I guess it's just not really. Yeah. It's not even geometry because we're giving points on the edges, so it's just yeah, the points might be equal. But what does it mean? Okay. W plus H plus W minus X. W plus H plus W plus H minus Y. I think so. Yeah, I guess. Whatever. Okay. Okay. Minus proof AI plus 1. Okay, I think this way. Let's see. Okay, just a yes. Not very informative, but let's submit anyway. Okay, A. Let's read A. Okay, it's probably not data structure problem, but what is it? Yeah, okay. Okay, problem G accepted. That's good. Okay, also B solved. Sure. Okay, what is A? A is just we have some swaps. Let's copy input. So yeah, we should apply like what is this? Weird. Is it square root? I probably can do it in square root. Okay. Okay. Yeah, let's see. So okay. How do I do this? So here's some permutation. Yeah. Okay, what's this? What's the example? Okay, 1, 2, 3, 5, 2, 4, 2, 4. I can ignore them. 1, 2, so it's 2, 1, 3, 4, 5, 6, 3, 5, 2, 1, 5, 4, 3, 6. 2, 6 is 2, 6, 5, 4, 3, 1, right? 1, 5. And 2, 1. Yes, okay. So I have some swaps of elements, like in some positions. Okay, now I want to know where some element goes. Yes, I want to know where some element goes. How to do that? Is it like this? Probably. Okay. And now okay. Let's see. No. Right? No. Yes. Yes. It's okay. No. Wait. BL. Yes. Okay, I guess. Okay, so this should be incorrect, but it should give the inverse permutation, I think. Okay, it just doesn't work because Okay, P of C and T I got it, but that's not all right. Why M? It should be M. Yeah, it doesn't really matter here, but what's going on? Okay. Okay, I should also add 1. Yeah, it's just inverse permutation. Okay, that's good. So now the question is, okay, this is what happens for operation 2. Okay, and what happens for operation 1? Something similar, but different. I want to find what goes into some position. I think it's just do all the swaps in reverse order. I feel like that should be the way. Whatever. Okay. This should be the same, and this, whatever. Yeah, I feel like something like this should do. Let's see. Yeah, Q. So good. Okay, B, E, F. Okay, B has the most submissions. What's problem B? Interesting. Time limit. Seriously. Just give me a break. What? Yeah, but like so what now? Yeah, it's just because of the module operation, right? Okay, let's just submit again. Whatever. What is this? Okay, so B, I just start in each vertex and I solve the problem for each vertex. I have some root, I have some tree. It's not a trie, but it's a tree. I want to somewhat like merge the vertices. So yeah, I think I just do GFS, which, okay, accepted. Whatever. Okay, I think it's just DFS where you have multiple vertices at every moment, something like this. Okay, vector. Okay. And this. 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 I think this is actually. Oops. Should be the same. So now is it even good enough? Yeah, I'm not really sure. Maybe. I guess there's just no. Yeah, should be of char int. Am I just going to have another time limit exceeded? Maybe. We'll see. Okay, and also another thing is yeah, let's see. And I think here it should have -1. Yeah, I think this is okay. Zero 310 108 36006. Okay. What's up with the languages? Okay, losing on penalty pretty badly. E and F. Okay, what is E? Runtime error, test case 3. What is this? Like seriously. One vertex? No, one vertex is not runtime error. No, really. What? Whatever. Like, going on. It cannot be. It cannot be. Well, it should not be Stack Overflow or something like that. Wait. Okay. Okay, this runtime error. After all. Yeah, I mean, what is this? Oh, so bad. Yeah, I don't feel good about this at all. Like yeah. Whatever. Who needs to win on penalty? What is problem E? I cannot even understand what's going on. Okay, be accepted, which is better than nothing. Three, two, 2, 1, 3. Okay. So I have 3 vertices, and I need to find 2 flows, which maximize the smallest of them, right? Yes, and then I don't know. Are the edges directed? I guess not. Also this, probably. No. Like this, right? Yes. Oops, I'm a bit confused. Okay, this is actually even not compiling. Because what? Yeah, like, what is this const? Have we even ever used this code? What is 6? Really? What is that? Mid or okay, this is just very bad. Okay. I see. Okay. Let's submit, but like I'm confused by this problem, honestly. Okay, C solved as well. So just solve everything, I guess. Okay, E accepted. Whatever. That's a weird problem. I guess it's okay. So what is F? F is just count something. What do I do? How do I do that? Kevin solved it, and who else? Okay, sure. So okay, I think it's just, yeah, if I rotate the picture, it's very easy, right? Yeah, I think just rotate and then it's actually easy. Okay. Okay, this is just dp of row. column, I guess, and count, I think. Okay. Oh, t+1. What is t+1? I don't know. Okay, it's h. Okay, h+1, whatever. t+1, 0. Okay. So in the last row I have 0 trucks and 0 in total, which leads to, okay, I have one way. And now I have some row. So yeah, by default I have one more truck. Okay, whatever. I guess. I don't really need another thing, but it's okay too. Okay, and then like this. Like, what am I doing? Okay, maybe. It's a bit sketchy, but let's see. Okay, maybe not so sketchy. One. Okay, let's submit. Okay, I've accepted. Only C left. And 32 minutes. So At the same time, the participant with the lower number is considered to have arrived earlier. Okay. Time in which distance 1 is covered. So t times distance is the actual result. Then I have t minus something, but then yeah, I have some constant there. Okay, so this should be something easy. Yeah, I have a lot of checkpoints. Oh yeah, D is the same. That's important. Okay. Yeah. Okay. Mm-hmm. Let's copy the test case. Whatever. Okay, so each I think changes my time by some. Okay, what should I find? Expected place. Okay, yes. Okay, what do I want? I want some polynomials. How many of them? M+1? Probably. No, actually M, right? Yes. Okay. X plus 1 minus xi. Yeah. Okay, dist plus 1, probably. Right? Mint. And yeah, okay. So with probability P, I add something with probability minus 1 minus P. Okay. Let's compile. It doesn't because, okay, not P, I. Mm-hmm. Okay, now what? I want to find the expected place. I want to find probability that someone beats me. How do I do that? Okay, my time. Okay, let's just do this and then we'll. I don't need this. Right. Okay. Yes. Okay, my time. What is my time? My time is t0 times x, right? Just simple as that. Oh, I have two participants. Yeah. What to do then? Yeah, have two participants, then it's a bit trickier, but not by much, right? Right. Yeah. Okay, it should be 2 times this in this case. There is no change. Yes. Okay, this is just delta, which is minus ti times L, I think. Okay, then let's make a slow solution first, and then we'll just optimize it. Something like this, I think, should almost be correct. Okay, smaller than size, of course, and here. Yeah. Okay. Let's think. Okay, also the change is 2 times d, first of all, right? Okay. Okay, I have enough time. Just figure out the formulas. So I have two things, right? Like tracks of length 21, so I have 20 different, right? Yeah, I think so. Okay, so I have 20 different line segments. Okay, what is the difference? So my time is t0 times L, their time is ti times L, right? Right. Then the difference is like this. So I actually lose if their time is smaller. Right, so I actually lose it if it's positive, but it will not change the answer, I think. in this formulation. It will, okay. I guess just whatever. So now the question is how to optimize this. I need some, what's that? Some suffix? Yes, some suffix. And here, I don't know, let's just do binary search. Okay. Is it good enough? Okay, let's see. I think it's okay. Okay, dokie. Okay, done. In an hour, that's fine. Hi everyone. Let's stop the timer. First place, not sure. Yeah, first of all, Kevin can definitely beat me. If his F is correct and he passes A, he beats me. Yeah, Golovanov cannot beat me. Well, can. He actually can if he just solves C with a blind submission. And yeah, also a couple of contenders below as well. Done already, yeah. GG. You're afraid I would not finish in an hour? You were afraid. Why be afraid? Don't be afraid. Okay, we'll get to know the results in 18 minutes. In the meantime, yeah. Who knows the problems? Who would like to discuss them? Who has any insights on what I was doing? What's the benefit of submitting blind? It's just, yeah, negative penalty. Should have submitted blind F. Yeah, maybe. I think it's okay. Like, I don't really want to. I just want to only do open submissions and then see where it can lead me. But if someone uses blind submissions to their advantage and actually beat me, I'm totally fine with that. So, A can be done on linear time. Okay, that's a good insight. Yeah, I have not taken the Stanford course, so I cannot recommend or disrecommend that one. A can be done in linear time. Okay, problem A. So on problem A, we had some... Okay, we are kind of maintaining a permutation and we have some swaps, like swap positions A and B. And then we have some sequence of swaps. Okay, let me just show the example. So I should maintain permutations of length 6. I have a sequence of 7 swaps, which are given below, like swap elements on positions 1 and 2, positions 3 and 5, and so on. And I have 8 queries. And each query is, I have some type of the query, one or two. One means find the value of in a position after something, and two means find the position of some value after something. After what? After applying swaps from 1 to 7 in this case, like in this case 1 to 7 is all swaps, 4 to 5 means just these two swaps, and so on. And the question is like, if the query is of type 1, what is the element in position 1, 2, 3, 4, 5, 6, or where the 2 goes to. Could be the different type of query. Yeah, and I used square root. For type 2 queries, just simulate, and at the start of the query, see what's in a certain position. And the end of the query, see where it is. Let's see. Just simulate. Oh, you mean, okay, so first of all, it's an offline solution, right? Sometimes I miss these things. Like, you can solve a lot of problems offline easier than online, but I was probably trying to do it online for some reason. But yeah, you can just do it offline, and then you kind of want to split a query into two, right? Yeah, like on two prefixes. If you have a query from 4 to 5, you have kind of a query from 1 to 5 and a query from 1 to 3, kind of. And then at the start of a query, see what's in a certain position. Yeah, so for example, if you want to follow where 2, the value of 2 goes after some sequence, so first of all, so you just simulate, and then after, like if I have 4, 5, for example, after 3 swaps, you see what is in the second position, like what value is in the second position, right? And then when you go, like, because you want to apply the given swaps to the identity permutation. I didn't actually mention that in the problem, but like, yeah, the query is a sequence of swaps. If we apply that to identity permutation, what is the result, right? So yeah, you just take a look at where you go, like, yeah, okay, you look what is in position 2 after 3 queries, and then after that you look where this number goes, and that is the position where actually number 2 goes. Okay. Okay, nice solution. My explanation is horrible, kind of, but it's fine. Yeah. For type 2 queries, just simulate, and at the start of a query, see what is in a certain position, and at the end of the query, see where it is. Okay. Yeah, and then for type 1 queries, I guess it's just something similar, just with inverse permutations or something. Yeah. Okay, just offline, and yeah. Okay, that's pretty good, because like, if not for offline, I was thinking that maybe we can like maintain some 2 permutations and then just look at something, but I cannot save n permutations. I guess I can somewhat save them, right? I can probably do it online linear time too, but it's just a bit more, maybe not linear, but n log n. So I need some persistent array, something like that. But yeah, it's fine. Yeah, so judging by some nice solution comments in the chat, that's not what people use. You can solve online in n log n with binary lifting. Okay, I guess. I'm not 100% sure what it means, but it's okay. Trojan came up with linear algorithm for this kind of persistent array. Okay, actually I don't remember. Maybe I just don't know. It's okay. Okay, that was problem A. I wonder if yeah, you solved it in linear time. Did you solve it after the contest? The real cry-30. I wonder if most people did, like, yeah, okay, so Boris did some n log n. I wonder if people just did square root like I did. Or maybe they're just all smarter, which is pretty easy to believe. And then problem B was, okay, I have a tree. Okay, you solved it using more algorithm. Okay, that's some square root, but a different one. Makes sense. Problem B was some, yeah, I have a tree. I have a letter on each edge of the tree. I have some queries. The query is I have two vertices, A and B. I take the string of letters on the path from A to B, on the simple path from A to B. And then I want to compare the string to all other simple paths starting in vertex A. And I want to say how many of strings starting vertex A are lexicographically smaller than the string from A to B. And we can see that n is only up to 4000. So it means that we can do n square. And basically, if all the letters on the edges were distinct, like all edges had distinct letters, it would just be start in the root and then just do some DFS, like depth first search, starting from that root. And in each vertex, you go in alphabetic order, and just the order in which you visit the vertices gives the lexicographic order of all the strings starting in the root. And that's one way to do it. But that only works if all the letters are distinct, but otherwise you could have some equal letters. So instead of a depth first search where you have one vertex, I have a DFS where you have multiple vertices, like a vector. And it means that the paths to all these vertices are equal in terms of like the strings. And what happens next, I take all the edges going down from these vertices, like from multiple vertices. I sort them here. Maybe I can do that without sorting to not make it n square log n. I'm not sure. Like I can sort it in like a bucket sort in 26 times n instead of n log n, but that's not really better. But anyway, so I just put all the outgoing edges into buckets, and then I again go, again go to all vertices with edges equal to A, all vertices with edges equal to B, and so on, and do multiple DFS for like all these things. And yeah, I save the time when I visit each vertex. That's what I did. Are there any better approaches about this one? In the meantime, okay, 7 minutes until the end. We'll get to know the results soon. My solution passed in like 3.8 out of 5. So it's not really fast. Maybe there should be a better approach. So yeah, please share. Okay, let's take a look at problem C. Yeah. It's a bit of a, like, yeah, it's a bit complicated, but the main idea is that, yeah, we have some checkpoints, like the problem statement, as you can see it, like between some checkpoints with probability P, everyone moves, like has some extra time they take, like which is actually D times the length of this segment. And with probability 1 minus P, which is very neatly is like typed here, but actually if you take a look at the Russian statement, it's 1 minus P times P over 100, which is much better. But yeah, so you can maybe, if you want to make sure you read the formulas correctly, maybe you can switch to Russian here. But yeah, for some reason, automatic Google Translator just translate all ones into ones. So yeah, so with probability 1 minus P, you get some time subtracted from your actual time. And then, yeah, you have some n participants. Each one has some base time they take to finish the track. And then on each segment, each participant gets some plus time or minus time, which is d times the length of the segment. And d is the same everywhere. And the question is, what is the expected place of participant 1? And yeah, basically, for each, like, let's say we compare participant 1 to someone else. And for each segment, we have 3 options. If they both get the same outcome, both get plus time or both get minus time, nothing happens. Like the absolute difference of their times doesn't change. And the probability of that is p square plus 1 minus p square. Like, plus 1 minus p square. Yeah. And then with probability p times 1 minus p, we get slower and they get faster. And with the same probability, we get faster and they get slower. And by how much? By the length of the segment times d, but we don't need d here. We just do this, like length of segment, and we will multiply by d later. And then we actually represent all these like ways something can happen as polynomials of some degrees. The degree of which polynomial is like 2 times the length of this segment. And then we just multiply all these segments. Like this is somewhat similar to, I don't know, knapsack, where like you can take some element once or twice and then like, I don't know, like maybe you can do something else instead of polynomial multiplication here, but I think it's kind of like the best way to do it. Like it's a bit complicated in general if you haven't met such problems, but anyway, that's how you do this particular one. And yeah, then as I had in my slower solution, I haven't saved it, but anyway, so like if you have some delta of times, let's just find, like for some suffix of our resultant polynomial, we will be slower, and for some prefix we will be faster. So just find the bound with binary search. You can obviously just solve the equation actually here, just solve the equation on mid on here, and just don't use any binary search and add some values on the suffix. Yeah. Nice way of fixing division of negative integer using binary search. Do you mean that I like have 0 dist 2 times dist instead of minus dist 0 dist here, or or maybe this one, mid minus size over 2? Not sure which one you refer to, but yeah. Oh, ceiling. You mean nice way of using binary search instead of solving the equation. Okay. I think solving the equation is probably not hard, but it's okay. Okay, Kevin solved A, and if his F passes, he beats us, which is totally fine. Even if I submitted F with blind submission, I would not have enough penalty. If I submitted C and F in blind, maybe I could submit C in blind, but I don't know. Like I'm just not doing that, so it doesn't matter. Okay. No one in the meantime wrote anything about problem B, so I don't know about different solutions to B, but it's okay. Let's see the results in 7 seconds. Okay, actually, Umnik solved A as well in the last minute and jumped to 3rd place. And Golovanov tried C in the last minute but failed. And if he didn't fail, he would be 1st. But yeah, 2nd place is good. Congratulations to KSun48. And yeah, that was a good contest overall. We finished in an hour, so that's decent performance. I had some unnecessary incorrect submissions, but all was good. Problems were easier this time. Yeah, maybe. Probably easier than last time, yeah. Yeah. Okay, so yeah, problem D. We have some rectangle. We have some segments which go from, like, which cut the rectangle, but like we have actually line, like straight lines which cut the rectangle, and each line is given with 2 points on the edges of the rectangle. So like we have some segments actually which cut the rectangle, and each segment cuts the rectangle in 2 parts, and we want to know if there is a segment such that it divides the rectangle into 2 parts, and we want to know if there's a segment such that there are no other segments intersecting at like one of the parts. For example, like all the other segments should be in one of the parts, like not intersecting the other one. I don't know. So yeah, like yeah, first of all, we actually want to, like, we don't care that it's a rectangle. It could be a circle or like any other convex polygon or like figure in general. So first of all, we want to linearize our points. Like we want to number all the points on the rectangle, all the integer points, for example. So like, for example, here I have some function decode. Like the rectangle is from 0, 0 to WH. So first we take the lower edge and we just have X. Then we take the right edge, and for each point on that edge, its coordinate is Y plus the width of the lower edge. And then we take the top edge, like we go overall, like, okay, we go by the rectangle this way. I am not taking my iPad this time anyway. And like we number all the points and we get some idea of each point. And then basically we want to, like, we have a segment, we want to know that there are no other points strictly inside one of the 2 arcs. So we just count how many segments have some end at any point, and then we do prefix sums on this, and then we have some segment, we take, we swap the ends, we check if there's nothing strictly inside this segment, so that if the total is 0, if the total of used points is 0 strictly inside the segment, then we output yes, because this segment is good. And also the other way around, we check if there's nothing strictly outside the segment, before AI or after BI. If the total of this is 0, then again we print yes. Otherwise we print no. So that was my approach, and I'm pretty sure there are other approaches, but this is the one I found the easiest to come up with in the limited time I had. Yeah. Yeah, personally I think this round was easier than the last one, but I guess it's personal anyway. Someone found it harder, but then that's fine too. Okay, problem E, I'm not really sure. Like, yeah, you have some network and you want to find, like you have 3 vertices, V1, V0, V1, V2, and you want to find 2 flows from V0 to V1 and from V0 to V2, which are equal, which use the same network. So like you can push 2 different liquids through an edge, but you cannot, like the total of their volumes should not exceed the capacity of the edge. And then the question is, what is that maximum flow, x, so that you can push x flow from 0 to 1 and from 0 to 2 at the same time. And I just did binary search. I don't know if there's a better solution. There could be actually, but if you just do binary search on this, you just want to check if there is a flow, like exactly what I said. Like have 3 edges going from the source to V0 and then from V1 to the sink and from V2 to the sink. And at each iteration of binary search, you just set the capacities of these edges to 2 times x, x, and x, and you check if the maximum flow is equal to exactly 2x. If it is, then yeah, you can increase x. Otherwise, you have to decrease x. You solved E by finding flow from B1, finding flow from B2, and finding flow from both capped and minimum of first 2 flows. I'm not sure. So we find flow from B1. So you find the first flow. You find the second flow. Okay, let's take a look at the example, for example, right? So we have 2 edges, 1, 2, 3. The capacity of this edge is 2, and the capacity of this edge is 3. So you find flow from B1, which is 2, find flow from B2, like which is 3, and then you find flow from both capped at minimum of first 2 flows. Oh, okay. Capped at minimum of, capped at minimum. I see. So you find 2, 3, you take the minimum, which is 2, and then you find flow. Yes, that's probably correct. That's probably correct, but I think it's not really easy to... Is it easy to prove? I'm not sure. Like if you have some x flow here and you have some x flow here and you have, let's say, y overall, can you always make it y over 2 and y over 2? You probably can. You don't have a proof, but it feels like it should be correct. Yeah, I think that the thing is, like, if you have... Yeah, I don't know. Like, I'm not great at this kind of proofs. It feels like it should be correct. I agree with that. In any case, my solution took 3 milliseconds, which is probably good enough. But yeah, for larger constraints, this solution is better, the one from the chat, because it doesn't require binary search. All right. And what about problem F? Yeah, problem F was, it was a bit difficult to understand it, but basically you have some kind of a triangle. Like this. And the question is, like you're given the height of this triangle, it would be 5 in this example. And then the question is, how many ways are there to replace some x's with, I don't know, say o's, so that below each o you only have o's. Like if you have o here, you have to have o here and o here. Let's say you have o here, then you have to have o, like o's on both sides of this o, and then on both sides of those o's, and so on. So you kind of have some such pyramids. And the question is, how many ways can you replace some x's with o's so that this condition is satisfied and the number of o's is equal to t, another variable. And the trick here is to actually look at this picture rotated. I think it makes it somewhat easier. So if you just write down the diagonals, for example, in this case, it would be something like this. Like this is the same picture, but just rotated. And so, at least for me, that was important to see the problem in this angle. And now, like the condition that each O must have O's on the left and on the right is transformed to, in each row, we have some X's and then some O's naturally. And then we cannot have an X below an O. Like we cannot do this. If we have an O, we have to have an O below it as well. So it means that the number of O's in each row, like for example, if I have 3 O's, I have 2 O's here, 1 O here, 2 O's here, and 1 O here. O's. And the condition is that the number of O's in each row should not exceed the number of O's in the next row plus 1. Right? Yeah, I think so. So 2 must be not greater than 1 plus 1, 1 must be not greater than 2 plus 1, 2 must be greater than 1 plus 1. And yeah, these are the conditions. 3, 2, 1, 2 are the number of O's in these rows, and 2, 1, 2, 1 are the number of O's in these rows. Like, yeah. And so it just means that we have to count some arrays of numbers. Arrays of numbers A1, A2, AH, so that AI is not greater than AI plus 1 plus 1, so that each AI is from 0 to H minus I plus 1, I think, and the sum of AI is equal to T. So we have to count arrays of integers which satisfy these conditions. Yeah, I think that's how we transform this problem. And then after you did that, you just do some kind of standard dynamic programming, which is okay, I'll just write it down here, f of I, j, sum, which is number of ways to fill, let's say, AI plus 1, an, such that AI is not greater than AI plus 1 plus 1, like, okay. Let's write it like this. Whatever. This is the condition that should always be specified, so just no need to mention it here, but I mean that AI is equal to j and AI plus 1 plus an is equal to s. And then you, like, this is the number of states is h to 4, because I is the row index, which is up to 100, because h is up to 100, j is the value which is up to 100, and sum is up to 100 squared. And then if we just transition could be just try all values of ai minus 1, from 0 to AI plus 1, which is like J plus 1 in our case. And just make a transition to the new DP state, but that would be a slow, and you can make it faster using some prefix sums or something like that. Again, I will not explain this in very much detail, but there is my code, which is a bit weird, but like, yeah, I go from each ij to I plus 1j, so I increase the number of O's by 1 first, and then I allow decreasing by 1 any number of times, and then I increase the total by the number of O's in this current row, and proceed to the next layer of the DP. But you can, again, implement it also in many other ways. Okay. Okay, we have discussed the problems now. Hopefully those who were interested in how to solve them could find something interesting for them. Okay, yeah, I guess ICPC, is that the World Finals? Yeah, I guess the ICPC World Finals 2017, problem J. Yeah, I guess it has some similar ideas to today's problem E about the flow, about the flows. So yeah, you can check that out as well for some proofs and stuff. All right. Yeah, I'm gonna call it a day soon. Yeah, as often happens in these cases, when I explain solutions to my problems from like Snark News series, I'm not 100% sure who my target audience is. Like, probably it should be those who actually participated in it and probably can understand more high-level ideas than what I actually explain. But at the same time, I guess like for everyone to find something in it, it's good to have some low-level explanation as well. I'm not sure, like, it's hard to satisfy everyone. But anyway, that was my attempt at it. But probably for more low-level explanations, some Division 2 code forces and stuff are better in general. Yeah, KSUN 1. KSUN not 1, but 48, but also 1. And I got second. Omni got third, and Golvanov got first, and then, yeah, a bunch of people solved 4. Yeah. The 5th round is in 5 days, as usual. And this will be the final round of the series. I will be streaming it on the 31st of January, the same time, the same place, this Twitch channel, so be sure to follow it. For those watching on YouTube, you can follow my Twitch given in the description as well. Yeah, and congrats, Kevin. Tomorrow is the Code Forces, which has Division 1, so I will probably participate in it real time. And then there are some different Code Forces Division 2 and maybe at Coders, which, yeah, just follow and see for check for updates and check Code Forces as usual. to see when I stream. I will post it here in the streams part. Okay, so once again, thanks everyone, and hope you have a good night or day. Can you please share the build comment that you're using? You mean like the compile comment? There is some blog post in Codeforces about this. Yeah, there's this blog post which has a lot of different options that are useful, and my compile line is basically something like this, mostly. I'm sending the link in the chat if you want to take a look. Do you use your pinky finger for pressing the arrow keys? I use it for pressing the right arrow. I usually use different fingers for the left arrows, which maybe it's suboptimal, I am not sure. Probably it's okay. All right. Once again, see you all later and good night. Take care.